Chapter 3, The Reverend Evans Universe. The following chapter covers the subject of supernovae and the creation of our galaxy by recounting the accomplishments of the astronomer Reverend Robert Evans, who by day was a minister at the Uniting Church of Australia, and by night practiced his hobby of discovering supernovae in the vast sky. Using his telescope, he examined the vast skies in order to study the history of the sky. I say history because we do not see the stars as they are now, but we see them as they were when their light left them. This is because it takes many light years for the light from the stars to reach the Earth. For example, the North Star might have already burned out, but we have not yet received the news. Supernovae occur when a huge star collapses, causing a huge explosion, releasing the energy of 100 billion suns. They are so huge that if a supernova occurred 500 light years from Earth, the Earth would be destroyed. We see here that science is measurable. Usually, supernovae occurs too far from Earth to hurt us. Spotting a supernovae requires great memory. Imagine a huge parking lot with some salt scattered all over its ground. Then imagine adding one extra grain of salt to it. Reverend Evans would be able to detect it. That is how amazing his talent is. We see here that science is empirical. The word supernovae was created by an astrophysicist named Fritz Zwicky in the 1930s. He was also interested in neutron stars, which are compact objects that are created in the core of massive stars during supernovae explosions. A spoonful of matter from a neutron star would weigh 200 billion pounds. It is worth mentioning that only 2,000 stars are visible to the naked eye from Earth, 50,000 with stars with binoculars, 300,000 stars with a 2-inch telescope. The proposition of the existence of supernovae is falsifiable, since looking for supernovae is mostly a matter of not finding them. Once they are found, it becomes empirical evidence. Moreover, not finding supernovae allows cosmologists to find out the rate at which galaxies evolve.
Evans discovered a particular type of supernovae called ES supernovae, which always explodes with the same critical mass, which could allow scientists to measure the expansion rate of the universe through induction. In 1987, Saul Perlmutter created an automated system for supernovae hunting. Through the system, 42 supernovae were found in 5 years empirical. Now, let's examine an important question. What would it be like if a star exploded nearby? According to John Thorstenson, an astronomer, this is not going to happen unless the supernova is extremely close to Earth. If this happened, it would destroy the Earth's magnetosphere, which protects us from ultraviolet rays and cosmic assaults. However, we are sure that this won't happen because a supernova has to be a star 10 to 20 times as massive as the Sun, and there is nothing this big close to the Earth. Then why are supernovae important to us? Well, if we go back in time to the Big Bang, we will find out that supernovae are thought to have produced carbon, iron, and other materials that allowed for our existence. According to Fred Hoyle, who introduced the term Big Bang in 1952, an exploding star would generate enough heat to create all the new elements and spray them into the cosmos, where they would form gaseous clouds that could eventually coalesce into new solar systems. Today, scientists believe that 4.6 billion ago, a great swirl of gas and dust accumulated in space. Almost 99.9% of it went to make the Sun. From the rest of the floating material, 2 microscopic grains were joined by electrostatic forces, making planet Earth. It took 200 million years for the Earth to form. About 4.5 billion years ago, an object the size of Mars crashed into Earth, blowing out enough material to form the Moon. Before the Earth reached its final size at about 1/3 of its eventual size, it developed an atmosphere composed of carbon dioxide. Before the Earth reached its final size at about 1/3 of its eventual size, it developed an atmosphere composed of carbon dioxide, nitrogen, methane, and sulfur. Because carbon dioxide is a powerful green gas, it protected the Earth from freezing as the Sun was dimmer back then. In the following 500 million years, the Earth was continuously hit by comets and meteorites, which brought water to fill the oceans. That's when our planet was ready for the formation of life.